So, from what I can tell, I've gotten quite a few questions on the homework from section 5.3, which is implicit differentiation. I haven't gotten a lot of homework on related rates, but maybe I haven't done it yet. I am recording this Monday afternoon. So if you haven't looked at that yet or tried it yet, then you may not know where your problems are. So I'm going to make a video today for the homework from section 5.3. If I then need to make a video on the homework for section 5.4, I can do that too. We're going to do a test because really we're at the end of chapter 5. We're going to do a test on Monday, so a little bit more than a week. That gives us, today, all I'm going to do is make this review of the homework so that you can go through that. Tomorrow I will review chapter 5 and if need be make a video on answers to related rates. And then on Thursday, we will begin chapter 6. Again, it's a totally different subject. Like you're not going to confuse it. And then I will probably give you a long weekend to study. Like I'll probably give you the Friday to study. And if there's any questions I need to answer at that point or anything, we can do that. But then Monday at 2 o'clock, because that's our class time, Monday at 2 o'clock we'll do a test. All right? So that's how we're going to do that, I think. So I am going to go over all of the homework from implicit differentiation because there were quite a few questions and they were sort of all over the place. So I think it's just as easy for me to do it all. And you can just fast forward through the parts you know how to do. All right? That's the beauty of videos. You can play it as many times or as few times as you need. So, homework, implicit differentiation started on page 289. Page 289. Sorry, I lost my place. 2ACD. Let me write it on the side so that I don't have to keep looking over here. 2A, C, D, and G. 3A and D. 4A, B, and C, and 5A. That's what I have. So I'm going to do those, and we'll see how that all works out. So number 2 was just determine dy over dx. In other words, just do the derivative. So 2a, x squared plus y squared is 25. So in implicit differentiation, we're going to do the derivative of x, which is 2x. And then if you want to, you can say I did the derivative of x with respect to x. But that's just going to be 1 anyway, because dx over dx, anything over itself, is just 1 anyway. So I don't bother to put that. If I'm doing the derivative of the thing that I'm doing the derivative with respect to, I don't bother to put it. You can if you want to, but you don't have to. Plus, I'm going to do the derivative of y squared, which would be 2y. But again, I have to say that I did the derivative of y with respect to x. And the derivative of a constant is 0. Again, I could say I did the derivative of the constant with respect to x, but when I multiply it with 0, it's just going to be 0 anyway, so I don't bother to put it. So you could have this, or again, I don't bother to put that because it's just 1. And I don't bother to put that because it's all going to be 0 anyway. Because to me, that just looks cleaner. I don't get as confused. So I have 2x plus 2y dy over dx is equal to 0. So I'm going to move this over here. So I have 2y dy over dx equals negative 2x. So I want to get the dy dx by itself, so if I divide this side by 2y so that those cancel, I divide this side by 2y. What I notice at that point is that my 2's will cancel, and I really just have negative x over y. That's 2a. 2c. 2c, x cubed plus y cubed equals 17. Very similar. So again, derivative of this is 3x squared. You could put dx over dx, but in my opinion, why bother? This would be 3y squared. You do have to say dy over dx because that fraction doesn't work out to be 1. So I did the derivative of y with respect to x, and then the derivative of 17 is 0. Again, you could put, I did the derivative of the constant with respect to x, but it's not going to affect anything, so I don't bother. So I'm going to move this over here, and I'm going to have 3y squared times dy over dx is equal to negative 3x squared. I'm going to divide both sides by 3y squared so that that is gone. My 3's will cancel, and I have dy over dx is negative x squared over y squared. And I would be done. 2d. 4x squared minus y squared equals 36. So again, take the derivative of this. So when I bring my 2 down, that is 8x. Again, I could say I did the derivative of x with respect to x, but that's just 1, so I don't bother to put it. Minus, I could bring my 2 down, so I have 2y, and I have to say I did the derivative of y with respect to x, and the derivative of a constant is nothing. So here's what I have. So I would move this over here, so I have negative 2y, dy over dx is negative 8x. So I would divide this by negative 2y. I would divide this by negative 2y, so that that's gone. And I have dy over dx is negative 8 divided by negative 2 is positive 4x over y. And then that was d. And then g is, oh, this one's lovely. Okay, g is yucky. Just telling ya. G is y to the 5th plus x squared y cubed, and that's the part that makes it awful, equals 1 plus x to the 4th y. That also makes it awful. So there's actually a lot going on in this, even though this doesn't look like it should be a really confusing question. It is. So if you did not get 2g, I know why. So for this, if I do the derivative of y to the 5th, that's going to be 5y to the 4th, but I have to say I did the derivative of y with respect to x. This part messes everything up because I am multiplying the x squared with the y cubed. I'm multiplying two things together. See? I'm multiplying this and this. When I'm multiplying two things together and I want to do the derivative, I have to do the product rule. So this part would be f and this part would be g. The product rule says g f prime, so we're going to put this plus here, plus g, which is y cubed, f prime. Derivative of f would be 2x. So there is my g f prime. Plus, now we have to do f g prime. So f, leave f alone, which is x squared. Do the derivative of g. Well, that is 3y squared, but I have to say I did the derivative of y with respect to x. Again, over here, I could have said I did the derivative of x with respect to x, but I would have had dx over dx, so no need. So that's that part. Okay, now we have the equals. The derivative of 1 is 0. But again, look at this. I am multiplying my x to the 4th with my y. So again, this would be f, this would be g, and I'm multiplying those two things together. So I have to do the product rule again. I have to do the product rule, but with this now. So plus, now I have to do g, which is y, f prime, which is 4x cubed. And again, I could say I did the derivative of x with respect to x, but I don't need to. Plus, so that was my g f prime, plus now I have to do f g prime. So f would be x to the 4th. G prime, the derivative of y is 1, but I have to say I did the derivative of y with respect to x. So this all of a sudden got very, very long. So let me just, so I have 5y dy over dx plus y, I don't like y cubed 2x, I don't like it that way, it confuses me, 2xy cubed, that just makes me happier, and here plus, and again, I just don't like the 3 there, so I would write it 3x squared y squared dy over dx. No reason, it's not wrong to leave it like that, it just confuses my brain, and so to make it easier on my head, that's why I do that, is equal to, now that's nothing, so I can just drop that. Again, I don't like the order that's in, so I would say 4x cubed y. Again, no reason other than just personal preference, plus x to the 4th dy over dx. So I just cleaned it up a little bit, made it easier for my brain to handle. Now, there are pieces that have a dy dx in them. There's one here, there's one here, and there's one here. I'm going to put them all on one side. The pieces that don't have a dy dx, I'm going to move them to the other side. But watch your signs when you do that. Lydia, that's especially for you. All right? Watch your signs. Don't mean to call you out, but I'm calling you out. Watch your signs when you do that, because if you move something and don't change the sign, you're going to get the whole thing wrong. And that would be something I would do. So this is already on this side. I'm not moving it. So 5y dy over dx. This is already on this side. So plus 3x squared y squared dy over dx. I am moving this, though, from one side of the equals to the other, so minus x to the 4th dy over dx. So that's all the pieces that have a dy dx on this side. Over here, we have 4x cubed y, but we have to move that over to this side, so now it's minus 2xy cubed. Please don't try and subtract those. They are different. This is x cubed y. This is xy cubed. The exponents are different. So that's something that sometimes people will try and do, and it's not right. Over here, each of these pieces has a dy over dx. So I'm going to take it out as a common factor. dy over dx is here. If I take it out of here, I have 5y. If I take it out of here, I have 3x squared y squared. If I take it out of here, I have minus x to the 4th, and that's equal to 4x cubed y minus 2xy cubed. I need space. One of the things I miss about live classrooms, big giant whiteboard. Okay, so here is what I have down here. I'll just erase all of it, that'll be less confusing. So here is what I have. I want the dy dx to be by itself. So I'm going to divide this side by 5y plus 3x squared y squared minus x to the 4th so that it will cancel. But that means I have to do the same thing to the other side. So I'm going to have 4x cubed y minus 2xy cubed all over 5y plus 3x squared y squared minus x to the 4th. There's really nothing else I can do with that. I'm going to double check my answer because it's such a crazy answer. I just want to be sure I have it right. You can hear some of my dogs barking because, you know, they're like that. So chapter 5, section 5.3, 2G. 4x cubed y minus 2xy cubed, 5y to the fourth. Oh, did I drop a 5y to the, I dropped a fourth somewhere along the way. When I brought that down, I dropped a fourth somewhere along the way. Because when I did the derivative of this, it should be 5y to the fourth. If I didn't do that, somewhere I dropped it along the way, either right at the beginning or later on, I'm not sure. All right, so other than that, I was right. I just randomly dropped an exponent for some reason. So that's 2. So now we're moving on to 3. Three. Determine the equation of the tangent to the curve at the given point. So if I'm coming up with an equation for a tangent, I know I'm going to have to do y minus y1 is equal to slope times x minus x1, because that's the equation of the tangent. So for 3a, they give us x squared plus 9y squared is equal to 37 at the point 1 and 2. So I already can do y minus 2 and x minus 1. What I need is a slope. So to figure out a slope, I need to do the derivative. But because I have letters that are all on the same side, I have to do implicit differentiation to do the derivative. So 2x, and again I could say dx over dx, but I don't bother. I can bring my 2 down, so I have 18y. But here, because it wouldn't be the same letter over the same letter, I have to say dy over dx is equal to 0. I want to get the dy dx by itself, so I'm going to move this over here. So I have 18y dy over dx equals negative 2x. So I'm going to divide this side by 18y. I'm going to divide this side by 18y. So I have dy over dx. This would be negative x over 9y. So that is my formula for figuring out the slope. Now I have an x, it's 1. And I have a y, it's 2. So my slope is negative 1 over 18. So y minus 2 equals negative 1 over 18x plus 1 over 18. So if I move this over here, I have y as negative 1 over 18x, and that would be, what, 18 and 18 is 36, so that's 37 over 18. You can leave it like that if you want to. Doesn't bother me either way. Otherwise, you have to bring everything over to one side, but I'm fine with it in slope y-intercept, like y is equal to mx plus b. That's fine by me. So that's what you would have. That's 3a. 3d. Oh, another one of those. Y to the fourth plus x squared y cubed equals 5 at the point 2 and 1. So again, I can do y minus 1 and I can do x minus 2. What I need is the slope, so I need to do the derivative. The problem is going to be right here. I can see it already because I'm multiplying x squared times y cubed. When I get to that point, I'm going to have to do the product rule there, so it's going to suck a little bit. So y to the fourth is 4y cubed, but I have to say I did the derivative of y with respect to x. So here I'm multiplying these two things. So this is f, this is g. So the product rule would say g, which is y cubed, f prime, which would be 2x, plus, now I would have to leave f alone, which is x squared, do the derivative of g, which is 3y squared, but I have to say I did the derivative of y with respect to x. And that's going to equal 0 because the derivative of a constant is 0. So again, I will likely clean this up as I go, but I'm going to keep any piece that has a dy over dx, which is this piece and this piece. I'm going to keep it on that side. I'm going to move the other one to the other side. So I have 4y cubed dy over dx. That was a plus, and I don't like it that way, so I'm going to write it 3x squared y squared dy over dx equals, and I'm going to move this over, and again, I don't like it written that way, so negative 2xy cubed. I just like it in alphabetical. It's just my neuroses, it's fine. So here, I'm going to take dy dx out as a common factor. So I have 4y cubed plus 3x squared y squared is equal to negative 2xy cubed. So I'm going to divide this by 4y cubed plus 3x squared y squared. So I'm going to divide this by 4y cubed plus 3x squared y squared. So that is my derivative. That is my dy over dx. That is my formula for figuring out slope. So now I can do that my x is 2. So this is 2 times 2. And my y is 1, so times 1 cubed over 4 times 1 cubed, because y is 1, plus 3 times 2 squared times 1 squared. So that's a bunch of math that you either put in your calculator or do in your head. I probably know the answer to that. And so this is 4 over, this would be 4. 2 squared is 4 times 3 is 12, 12 plus 4. So this would be 4 over 16, which reduces to 1/4. So my slope is 1/4. From there, I'm hoping that you can expand that out. Y minus 1 equals 1/4 x minus 2 over 4, so minus a half. So if I move this over here, I have 1/4 x, negative a half, plus 1 is going to be plus a half. And you can leave it like that. I'm okay with it there. So that's 3D. I'm getting there, guys. So now, for ABC. Number 4, find the slope of the tangent at the given point. Find the equation of the tangent, and then we're not graphing. So, you only had to do 1 and 2. I probably should have said that, but I assumed you would know. Number 4, we're doing ABC. So, cool. They give us x minus 3 squared plus y plus 1 squared equals 16 at the point 3 and negative 5. So, y minus y1, so y plus 5, and slope times x minus x1, x minus 3. So I need a slope. And that's what number 1 is, find the slope of the tangent. So the first thing I have to do is find the derivative. Now, you have a couple of options on this, to be honest with you. You have a couple of options here. You can use the chain rule with implicit differentiation, or you can expand this out, and then I do it. I think I'll do it both ways. I know it'll take longer, but you can just fast forward through whatever. I'm going to do it both ways so that you can see the difference of how much work is involved, and you can decide for yourself. So the chain rule. The chain rule happens when you have more than just one thing inside the bracket. You have like a binomial or a trinomial. You have more than one piece inside the bracket, and that exponent is on the whole thing. The chain rule says do the outside first. In other words, bring this 2 down, leave the inside alone, and decrease the exponent by 1. So that would be x minus 3 to the first. Then, once you've done that, now do the derivative of the inside. Well, the derivative of x is 1, and the derivative of negative 3 is nothing, so I'm done. Over here, plus, if I again do the chain rule, I'm going to bring my 2 down in front, so I have 2 times y plus 1, decrease my exponent by 1. Then I do the derivative of the inside, but the derivative of y is 1. But again, I have to say that I did the derivative of y with respect to x, and then 1 is nothing. Equals the derivative of 16, which is 0. So really what I have here is I have 2 times 1, that's 2, times x minus 3, is equal to 2 times 1 is, plus 2 times 1, that's 2, times y plus 1, times dy over dx, equals nothing. So 2x minus 6, plus 2y plus 2, and that whole 2y plus 2 is times dy over dx, right? Because that's one whole piece. It's all multiplied together. So this, I can move over here. So I have 2y plus 2 times dy over dx equals, now again, don't forget to change sign when you move it over, negative 2x plus 6. Now I can divide this side by 2y plus 2 so that that cancels. So all I have left is dy over dx, and this would be over 2y plus 2. So that is my formula for slope. Again, I know what my x is, I know what my y is. So negative 2, x is 3 plus 6 over 2 times y is negative 5 plus 2. So that's negative 6 plus 6, which is nothing, and negative 10 plus 2 is negative 8. So my slope is actually 0. So I have y plus 5 equals 0. So y is equal to negative 5. That's it. So again, if I was graphing that whole thing, y is equal to negative 5 is just y is equal to negative 5. 1, 2, 3, 4, 5. Even if I asked you to graph it, that's all it is. All right. B, very similar. Oh, I said I was going to do that the other way too, didn't I? So if you did x minus 3 squared plus y plus 1 squared equals 16. If you decided to do the derivative by expanding it first, this would be x squared minus 6x plus 9 plus plus y squared plus 2y plus 1 equals 16. So now if I do the derivative, this would be 2x minus 6, and that would be 0, plus this would be 2y times dy over dx, plus this would be just 2, but again I was doing the derivative of y, so I have to say dy over dx. That would be 0, and that would be 0. So I would move anything without a dy dx, so I would have 2y dy over dx plus 2 dy over dx equals, if I move this over, negative 2x plus 6. It should be looking familiar. So if I take the dy dx out, I would have 2y plus 2 is equal to negative 2x plus 6. So to get the dy dx by itself, I would divide by 2y plus 2. So I would divide by 2a plus 2. I got the same answer, I just did it differently, and then I would do the rest of it the same as I did everything else. Sorry, there's a bug on the ceiling, I was looking at it. So B, now I'll go to B. So for B, y squared minus 2xy equals 11 at the point 5 and negative 1. So again, I know I'm going to end up finding the equation of the tangent. So I'm going to do y plus 1, and I'm going to do x minus 5. What I'm missing is that slope. Slope means I have to find the derivative. So to do the derivative, this is going to be 2y dy over dx. The confusing part is here because it looks like I have 3 pieces. Now I'm going to subtract everything from here. I'm going to call 2x f, and I'm going to call y g. And I'm going to do the product rule with that because, again, I'm multiplying pieces. So if f is 2x and y is g, I could have actually even broken it up as x and 2y, but that would be weird. But you could do it. But the thing is, you have to get your x and your y separate. So g is y, f prime is just 2, plus f is 2x. The derivative of y is 1, but again, I have to say I did the derivative of y with respect to x. And that's equal to the derivative of 11, which is nothing. So again, this is just g f prime plus f g prime. That's all that is. I don't know why I put my primes down there. Okay, so 2y dy over dx minus 2y, again just cleaning it up, and again minus, because again the minus goes with both of them, don't mess up your signs, so minus 2x dy over dx equals nothing. So I'm going to take this piece, which doesn't have a dy dx, and move it over here. So I have 2y minus 2x, sorry, 2y dy over dx minus 2x dy over dx, is jumping ahead, is 2y. I'm going to take the dy dx out as a common factor. So I have 2y minus 2x is 2y. So I'm going to divide this side by 2y minus 2x. So I'm going to divide this side by 2y minus 2x. That is my slope formula. So now it's just a matter of sticking the numbers in. So 2 times negative 1 over 2 times negative 1 minus 2 times 5. So that's negative 2, and that's negative 2 minus 10, which should be negative 12. So that is 1 over 6. And then you just clean that up from there. My guess is this was the problem, not that. And finally, for C in this section, looks lovely. For C says x squared plus y squared minus 4x, I think it was, yep, plus 6y equals 87, I think it said, yep. And the point is 12 and negative 3. So again, finding the equation of the tangent, y plus 3 and x minus 12. What I'm missing is the slope. So derivative of x squared is 2x. Derivative of y squared is 2y, but I have to say I did that with respect to x. Derivative of 4x is just 4. Derivative of 6y is 6, but again, because it was a y, I have to say I did the derivative of y with respect to x. Derivative of 87 is 0. This one's actually easier than the last one because there's no product rule in it. So anything that doesn't have a dy dx over to the other side, so 2y dy over dx plus 6 dy over dx equals negative 2x, because I brought that over, plus 4, because I brought that over. So 2y plus 6 times dy over dx equals negative 2x plus 4. So just divide both sides by 2y plus 6. I don't know why I put my bracket around the dy dx rather than the 2y plus 6. No reason. I just did. So dy dx equals this. So to figure out my slope, negative 2 times 12 plus 4 over 2 times negative 3 plus 6. Here's the catch on this one. This ends up being negative 24 plus 4. It ends up being negative 20 over 0. But you can't have anything over 0, so it's actually undefined. When your slope is undefined, what that actually means is it is a straight line up and down. It is just an x value because it goes all over the y's. It goes all up and all down. So really it's just that x is equal to 12. Okay? This just ends up going away because of this undefined. It's just what happens. An undefined slope is a weird situation. All right. 5a. 5a. It's the last one for calculus. Yay. I feel like this is like the forever video. I am not giving you any work other than to do this. 5a. Find an equation of the tangent to the circle x squared plus y squared minus 6y, nope, minus 6x plus 2y equals 15 at the point 6 and 3. Now, they don't say find an no, they do. They say find an equation of the tangent. So again, y minus 3, x minus 6, looking for a slope. Slope for this one is not bad. 2x plus 2y dy over dx. I hope this is clicking at this point. Minus 6, because I just did the derivative of 6x, plus 2, because the derivative of 2y is 2, but because it was a y, I have to say I did it with respect to x, and that's equal to 0. So, 2y dy over dx plus 2 dy over dx equals negative 2x plus 6. I just moved that over there and that over there. So 2y plus 2 dy over dx, taking out the common factor, is negative 2x plus 6. So I'm going to divide this by 2y plus 2. So I'm going to divide this by 2y plus 2. So I have dy dx is this. So to figure out my slope, I know that my x is 6, my y is 3. So negative 2 times 6 plus 6 all over 2 times 3 plus 2. So that's negative 12 plus 6, that's negative 6. And 6 plus 2 is 8, so that's negative 3 over 4. And again, I would just leave you to expand that out because that's little. All right, that was a lot, but we have now gone over the homework. Don't forget, you're going to have a test on Chapter 5 on Monday of next week. So you have all of this week to get any of your questions answered that you need answered, all right? So I will do a video on related rates if you need it, and I will do a review video for you. All right, talk to you again soon.